So in this lecture, we are going to discuss about total quality assurance and quality control program and their cost implications. So quality control. First, describes that quality control is a collective term for activities and techniques within the process that are intended to create specific quality characteristics. Such activities include continually monitoring process, identifying and eliminating problem causes, use of SPC to reduce the variability and increase the efficiency of the process. Quality control certifies that the organization objectives are being met. Okay, so as the author said, like quality control is a collective term within the process, which intended to create certain quality characteristics. Okay. So here we are going to use some techniques called SPC, statistical process control, to reduce the variability and also increase the efficiency of the process. Okay. So another author refers to quality control as a process employed to consistently meet standards. So it is just a process which is employed to consistently meet standards. The control process involves observing actual performances, comparing it with from some standards, and then taking action if observed performance is significantly different from the standard. So whenever it is deviating from the standard, then we are going to take some corrective action. This control process is a nature of feedback loop. So you can see here, process sensor goes to comparison and then goes again to the process. We're going to check whether it is deviating from the actual performance. So control involves a universal sequence of steps as follows. Choose this control subject, that is choose what we intend to regulate, establish measurement, establish standard of performance, product goal, and process goals, and measure actual performance, compare actual performance against the standards, and take action on the differences. That is what the steps involved in this particular sequence. Okay. A chunk defines quality control as referring to this activity that are carried out on the production line to prevent or eliminate causes of unsatisfactory performance. In the manufacturing industry, including production of ready-mix concrete, the fabrication of precast units, the major functions of quality control are control of incoming materials, monitoring of production process, and testing of finished product. From the foregoing, the quality control can be defined as a process of analyzing data collected through statistical techniques to compare with actual requirements and goals to ensure its compliance with some standards. So quality control defined, what they're trying to say is basically analyzing some data through statistical techniques and comparing with some actual requirements. Okay. Quality control in projects performed at the various stages through use of various control charts, diagrams, checklists, etc., and can be defined as checking of executed installed works to confirm that work have been performed, executed as specified using specified materials, installation methods, and specified references, codes, and standards to meet the intended use. So this is the thing that we do in the quality control. Controlling budgets, planning, monitoring, and controlling project schedule. So we already discussed in the earlier slide that quality control, in the quality control, we used to optimize both cost and duration. Okay, the project cost as well as duration is optimized. Okay, that is one part of one role of quality control. Okay, in construction projects. The control chart is a graphical representation of the mathematical model used to detect changes in the parameter of the process. So the charting statistical data is a test of the null hypothesis that the process from which sample came has not changed. The control chart is employed to distinguish between the existence of stable pattern of variance and occurrence of unstable pattern. So from this particular method, we can able to find whether there is any changes in the parameter of the process. If there is any unstable, we can able to detect it and we can make sure that some actions have been taken to minimize that effect. Okay. If unstable pattern of variation detected, and action may be initiated to discover the cause of instability. Okay. There are variety of methods, tools, and techniques that can be applied for quality control and improvement process. These are used to create an idea, engender planning, and analyze the cause, analyze the process, foster evaluation, and create a wide variety of situations for quality improvement. These tools can also be used during various stages of construction projects. So these are some tools that we generally use in different stages of the project. Okay. So there are the following are the very commonly used quality control tools for the variety of applications to improve the quality process. So we're just going to explain different tools, commonly used tools in quality control process. Cause and effect diagram, check sheet, control chart, data collection flow chart, program parent analysis, chart, run chart, scatter diagram. Okay, so we'll discuss one by one. That is these tools can be applied at various stages of construction projects to analyze causes of detection and take necessary preventive or remedial action. Okay, so causes of prevention and they take necessary action and develop a system for preparation and analyze processing the design drawings, documents, execution of works, processing of drawings, tabulation of data in the form of checklist, preparation of construction schedule requirements, and many other applications. So they have different applications. These tools have different applications and they applied at various stages of projects. Okay. Only then we can able to reject the causes and take some necessary remedial action. Okay. These are the cause and effect diagram for bad concrete. So from this diagram, you can say that these are different input. If it is not properly given, then we can say the bad concrete is produced. Okay. For example, you take this parameter, that is manpower. So in the manpower, if there is there is incompetent labor or improper supervision. So if these two things will happen, then it happens, then it ultimately produces bad concrete. So in the material, you can say cement, aggregate, water, design mix, all those things have to be properly given. Machine, vibrator, pump, and mixer have to be properly given at the from guidelines. Okay. Method, improper curing, improper pouring, non-continuity in casting. All those things will lead to produce bad concrete. Okay. So this is one example of cause and effect diagram for bad concrete. Okay. So whatever if this happens, then we can say this will happen. Okay. That is why it is cause and effect. So cause and effect diagrams is also called as Ishikawa diagram or fishbone diagram. Okay, fishbone diagram. It is used to organize and graphically display these multiple causes with particular effect. Figure illustrates an example of cause and effect diagram or bad conflict. Okay. A check sheet is a structured list prepared from the collected data to indicate how often each item. Okay, so we'll see the table in the next slide. The control chart is a fundamental tool of SPC, statistical process control. It is a graph used to analyze the variation in the process. By comparing the current data to historically determined lines, one can arrive at a conclusion regarding whether the process is stable or is being affected by a special cause of variation. There are many types of control charts. Each is designed for a specific kind of process or data. A control chart employed to distinguish between the existing existence of stable patterns of variation and occurrence of unstable patterns. So this is a typical diagram of check sheet as well as control chart. So from this control chart, we can say that it is an example. So you can say our values have been marked here in this particular line. You can say all those values which is marked here is coming under the two limit, that is one is upper limit and one is lower limit. So whenever we draw this, the control chart diagram, we will have two limit, that is upper limit and lower limit. So whenever our data is coming under this particular limits, then we can say that it is in control. Okay. If, for example, if I'm drawing a limit chart, okay, if I have something like this, okay, the line is like this, my upper limit is here and the lower limit is something like here. So if the point sometimes comes out of the limit, then a particular point or lot will be rejected. So this will be rejected. Okay, so it is rejected. So this whatever the the items which is comes under the upper limit and lower limit is what we have to take. If it is coming under, over the upper limit or over the lower limit, then the particular item or not be rejected. That is a prime purpose of doing this, drawing the control chart. Check sheet is nothing but we are going to list out the items, okay, and we're going to say whether the approval record approved or not approved, whatever the total, and what is the percentage of not approved. Okay, that is what the thing we are going to develop here. Check sheet. So data collection objectives is to identify the problem, report the problem, verify the problem, analyze, and correct the problem. So these are the different steps involved in data objectives. A flow chart is a pictorial tool that is used for representing a process in sequential order. Flowchart can be applied at all stages of project life cycle. Okay, so this is a flowchart that we are going to discuss. That is, you can say in this flow chart, there is a farm work, rebar work, embedded service, and submission of checklist. From this, we are going to take some inspection. If it is yes, then we are going to order for concrete and pouring the concrete. So we have to do all those things prior to the pouring of concrete. Okay. If you don't do this and directly pour the concrete, yeah, then we will face some consequences and we have to take some corrective action. That is why we are doing all those, in the steps. Okay. So this is one method, okay, flowchart method we follow in the quality control process. If during the inspection, if it is no, then if something happens or something we need to change, we have to go for again the rebar work. We are going to do some changes and we are going to do some inspection again. We are going to order the concrete and pour the concrete. Histogram. Histogram is a pictorial representation of a set of data. It is created by grouping measurements into cells and it displays how often the different values occurs. So you can say the graph, the different bars have been drawn here. Okay, like this. So you can see here, this is one type illustration of manpower versus frequency of occurrence, accident occurrence. So this is method of drawing some, representing a data, pictorial representation of data, and from this we can arrive some, correlation, and we can able to control the project. So in quality control as can be proceed. Okay. So Pareto analysis. Pareto analysis is a graphical representation of frequency of occurrence. So these Pareto charts are used to identify those factors that have greatest cumulative effect on the system, and thus significant factors can be screened out from the process. Okay. Pareto analysis can be used at various stages in a quality improvement program to determine which step to take next. So from this we can say the analysis like total number of construction cost and cumulative percentage is given here. So from this we can say there is the chart. There is a line drawn here like cumulative effect, something like this. So it goes up to 100 percentage from the starting this particular occurrence. That is, whenever we do owner modifications, design error, design changes. So we are going to plot like this, and we are going to draw the line like this. Okay. So this is the cumulative percentage. The total number of occurrence is given in the left hand side. We are going to give a bar chart like this. A pie chart is a circle divided into wedges to depict the proportion of data or information in order to understand how they make up the whole. Okay, so from this, that is a construction 89% supervision and design. So this is like dividing the proportion of data. Okay, portions of entire cycle are by sum up to 100%. Okay, this is called like pie chart method. A run chart is a graph plotted by showing the measurements against time. A run chart used to know the in the trend or changes in the average, and also to determine whether the pattern can be attributed to common cause of variation or if special causes of variations were present. So there is a figure which illustrates a run chart for manpower at the site for a particular week. It is similar to a control chart but does not show control limits. So it is almost similar to control chart, but it is not like that. Okay, so you can see here it is a graph which is drawn from between the manpower and weekdays. So you can say that the line has been drawn, the data has been drawn like this. So the average is drawn like this, the average mean value. So from this we can able to arrive that this particular 300 value, that is this particular data is very much have some more variance from the average when compared to other data. The other data is almost nearer to the average value, but this particular values have so much deviation from the average. So this is one way to make sure our the product or data are being properly have some quality issues or not. Okay. In such a way, we can eliminate those things. Okay. So the quality assurance program. So according to ISO, quality assurance defined as a set of activities whose purpose is to demonstrate that an entity, that is product, process, person, department, and organization, meets all quality requirements. QA activities are carried out in order to inspire the confidence of both customers and managers that all quality requirements are being met. According to ISO 9000, quality assurance is those planned and systematic actions necessary to provide adequate confidence that a product or service will satisfy given requirements for quality. According to ISO 8402 1994, defines quality assurance as all the planned and systematic activities implemented within the quality system and demonstrated as needed to provide adequate confidence that is entity to with fulfilled requirements for quality. Quality assurance is the activity of providing evidence to establish confidence among all concerned that quality related activities are being performed effectively. So that is one way to define it, quality assurance. All these planned or systematic actions are necessary to provide adequate confidence that a product or service will satisfy given requirements for quality. Quality assurance covers all activities from design, development, production, installation, and servicing to documentation and includes regulations of the quality of raw materials, assemblies, products, and components. Service related production and management, production and inspection processes. Quality assurance in construction projects covers all activities performed by the design team, contractor, and quality controller to meet owner's objectives as specified and to ensure that project is fully functional to the satisfaction of the owners slash. In the context of construction, quality assurance include all the planned and systematic administrative and surveillance functions initiated by project owner or regulatory agents to enforce and certify with adequate confidence compliance with established product quality standards to ensure that completed structure or its components fulfill the desired purposes efficiently, effectively, and economically. So the increase in complexity in the project has further increased the need for more efficient QA measures to ensure compliance with contract specifications. Quality assurance program encompasses the following: establishing the a procedure for defining, developing, and establishing quality standards in design, construction, and sometimes operational stages of the structure or its components. So these are different, activities involved in quality assurance. Okay. Establishing the procedure to be used to monitor, test, inspect, measure, and perform current and renew activities to assure a compliance with established quality standards with regard to construction materials, methods, and procedures. Defining the administrative procedures and requirements organizational relationship and responsibilities, communications and information patterns, and other management activities required to execute, document, and assure attainment of established quality standards. It is commonly observed that engineers, contractors use the term quality assurance and quality control interchangeably. Not correct. While QA is a construction management process and QC is a sampling or inspection process, the focus in QA is on defect prevention, while the focus in quality control is on defect detection. Okay. So in the quality control, we are going to detect the defect. The quality assurance is to prevent the defects. Okay. The main objective is to prevent the defect. Okay, the quality assurance. While the quality control team will make sure that quality is being detected. That's I mean defects have been detected once the item is constructed. So we are going to detect the defect. That is called quality control. Quality assurance means we are going to prevent the defect. Prevention of defect is very important. Yeah. So both are not same. In fact, it is said that quality control is a element of quality assurance program. So it comes under quality assurance. So quality control is comes under the quality assurance program. Cost of quality. Construction projects are capital intensive and cost of quality acquires great significance. According to Juran, the cost of quality considered in terms of economics of conformance quality, the quality cost is equal to quality control cost plus failure cost. Whereas quality control cost is equal to prevention cost plus appraisal cost, where the failure cost is equal to internal failure plus external failure cost. So this is a basic expression for quality cost. Whenever people say quality cost and cost of quality, you have to make sure that these two things are coming into your okay, that is quality control cost and failure cost. Internal failure, external failure. Quality control means prevention and appraisal. So the prevention cost used in the above equation refer to the cost of quality control activities undertaken before and during the production. In other words, prevention cost is the cost of effort undertaken to prevent the failures. The appraisal cost is given by the cost incurred for quality control or quality assurance after production. For example, the cost of inspection, testing, and examination to assess that the specific quality is being maintained. So internal failure cost means the cost resulting from product or service failing to meet quality requirements. Example, warranties, return liability cost, product recall cost, direct cost or allowances. You can say there is a the drop when you thought like quality cost means quality control and failure external and internal, quality control means prevention and appraisal. External cost includes costs relating to demonstration and proof evidence to customers, cost of testing by recognized independent testing bodies for quality assurance provisions, demonstration and assessment. Whatever the cost we, uh, you know, uh, cost we, uh, money we spend for the independent testing bodies. That is what external assurance cost. Cost of independent third-party agency performing detailed and in-depth study of the company's QA activities. So those are the things comes under external assurance cost. So the prevention and appraisal cost being optionals, they have to be referred to discretionary or controllable cost. The failure refers to a non-achievement of requirement. For illustration, let us take an example of leaking roof. The cost associated with this will be described below. For example, take a conformance cost, that is prevention and appraisal. Prevention means this includes the cost of various components that helps to prevent the defect, such as prevention of specification, procedure for construction, joint preparation, skipping time of farm work, and training of staff and work. So these are the costs that you spend to prevent the defect. Okay. So these are the things that you will be doing. Okay, preparation of specification, skipping time of farm work, training the staff, a work procedure. All those things are you're spending money and time so that it is not defect is not happening. Okay. Appraisal means this includes cost of all activities result in the cost of checking whether it is right. In this case, it will include checking the concrete making materials against agreed specifications, inspection before placing concrete, calibration and maintenance of equipment used for testing the concrete, and assessment and approval of all supplies. So we spend money on inspection, some money on maintenance of equipment. Okay, so those are the things that is comes under appraisal cost. Okay. Um, Organization in construction industry spend money in prevention and appraisal, but magnitude of these costs is very less when compared to total cost of the project. It is widely believed that if the prevention and appraisal costs are more, that is, the cost of conformance is more, the failure and non-conformance cost will be very less. So typically, while the conformance costs are controllable variance and non-conformance costs are resultant variable. Okay, so just make sure that you underline that these conformances are controllable variables. Non-conformance are resultant variables. So from this, graph, you can say the y-axis cost and x-axis defects. So the prevention plus appraisal cost, it starts with, you know, it generally starts like this. That is, when there is 100% defects, the cost of the money will be zero. Whenever the defects are decreasing, whenever you spend money on prevention and appraisal cost, the defects will be very much low. Okay, that is zero defects, and the cost of spending money will be more. Okay, that is why the curve is like this. So when it comes to cost, there is the failure cost. The cost is will be very high when there is 100% defects, and when it comes to time and again, the quality level is getting enhanced. There is zero defects. Yeah, the cost is also very much. So you have to make sure the total cost is very optimum. Like this, you have to spend minimum amount of money, not excess money. If you spend excess money, then it is not, proper way to do it. Okay. Non-conformance cost. This has two main components, internal and external failure cost. Together, they indicate the cost of getting it wrong. So the internal failure cost means the cost due to wastage of materials, crowding the roof slab by waterproofing compounds, and re-examination of works that have been rectified. So whatever the the work where we do for re-examination and the wastage of materials that took place, all those are internal failure due to our failure. Okay, external failure means repairing and servicing the defective parts. So the replacement of flooring compound, including transportation costs associated with the handling and servicing of customer complaints, impact on reputation and image, which impinges directly on future prospect of sales. So these are our external failure cost. Okay, we are spending money on that, due to external factors. Organization in industry spend more money on prevention and appraisal, but magnitude of these costs is very much less when compared to the total cost of the project. It is widely believed that if the prevention and appraisal costs are more, that is the cost of conformance is more, the failure and non-conformance cost will be less. Typically, while the conformance costs are controllable variables, the non-conformance costs are resultant variables. So this is from our lecture, and these are the references which I've taken to prepare this lecture material. Thank you.